Well, first of all, I'm apologize for the inconvenience and incident that I had during the presentation of the team. My son was very ill and he has not access to the child care because he has this chicken pox and I have no nanny at the time, so it was very difficult for me to concentrate. However, because I did not feel comfortable with my participation, not because I did not study or follow up, it is just because the circumstances at the time. So I'm making this video because it's something that I would like to say when I was in the class. Well, this is a business case, real case scenario of RSA company that happened during the COVID. Actually, before COVID, this RSA company was a startup and it grew up to $25 million a month. During the COVID, many companies face very strong challenges. So we have a shortage of labor, shortage of semiconductors, and also a completely global disruption in the supply chain. So with these constraints, for RSA, the sales dropped 25% and the production fell from 55,000 TVs per month to 15,000 TVs per month. This represents around 70, a little more than 70% fell from 55,000 to 15,000 drop. So under these circumstances, we need to focus in a roadmap to see how do we can optimize our inventory, optimize the cost, and more important, to analyze the data to see if we want to be in business or we don't have to be in business because there is no benefit. Okay, so in the cost control was developed. So the key solutions include optimizing the ordering. So we use a formula, the EOQ, which is the economic order quantity, which is the square root of 2 times the demand multiplied by the setup cost divided by the cost of inventory. So in this also case scenario, we have a constraint that 75% of our sales were through a channel, a retailer, which in this case was Walmart. 75%, it's a lot of risk. So we need to diversify that by creating another systems like direct to customers using electronic platforms. So the final conclusion for the RSA case is that RSA remains profitable and poised for recovery with discipline and execution, operational resiliency, strategic adaptability. It's one of the most important things for the company. And then hoping by the data analytics, the study that we did, that post-pandemic profit levels will be achieved during the next year or couple years. So we did, first of all, the mathematical behind that was to calculate the capacity and utilization analysis. And we break it in 2 parts, the pre-pandemic and the post-pandemic. So pre-pandemic, so the assembly plant was processing 55,000 TVs per month. And the RSA monthly sales were 2,976 TVs per month. The utilization, it was divided, it's the quantity of the 2,976 divided by the 55,000 multiplied by 100, and that is equal to 5.4%. Okay, utilization was calculated by dividing the monthly sales in the numerator, and in the denominator was the capacity. That multiplied by 100 to have in percentage will give us the utilization rate, which in this case is 5.4%. And so we were around 1,000 units produced in half a day. That was what we were doing, producing 1,000 TVs in half a day. That is pre-COVID, pre-pandemic. During the pandemic, we have the assembly plant capacity drops from 55,000 to 15,000 per month. The RSA monthly need, the drop that we have in sales, it was from 2.9 TVs per month to 2.2, which is the 25% decrease. So we recalculate utilization during the post-COVID, and that gives us the 2.23 divided by 15 multiplied by 100, and we got an utilization of 14.88%, almost 15% utilization in post-COVID. Compared to pre-COVID, it was utilization rate of 5.4%. Now, we use as well the news vendor model for optimization service level. So the shortage penalty that we have if we do not provide enough TVs for the demand at Walmart, it will be a penalty of $30,000 US. And if we overproduce or overprovide TVs in the stock, we're gonna pay a penalty of $25,000. Obviously, the under demand to have an unsatisfied demand is more costly for us. Okay, so to calculate the service level that we want, we take the 25,000, right, which is the exit penalty, and with which is the lower bound of that penalty, divided by the 25,000 plus the 30,000. So that gives us a 0.545 or 54.5 if we multiply by 100. This means that the company should plan to meet demand at 54.5 percentile of forecasting distribution, which it means that we are very close to the mean. In other words, if we have a normal distribution and we have the mean value at 0.5, and if we can calculate to be very current in this demand, so at this point we are in 54.5, quite close to the demand, quite close to the mean value, okay, to the mu. Okay, the other mathematical equation that we used was the EOQ, which is the economic order quantity. Economic order quantity calculation pre-COVID, so we calculate raw materials, $300, assembly, $150, short storage in China, $12.50, shipping, $15, warehousing, $12.50 per TV. So using the EOQ, which is the economic order quantity formula, square root of 2 times the demand times the setup cost divided by the storage cost, that gives us a total of it gives us a total of 9,258 units. This is the amount of TVs that we should ordering per month in pre-COVID landscape. During the COVID, or I say before post-COVID, so we recalculate. So the raw materials went to decrease from 300 to 285. All this is because the research that we did in providers and analysis of the data at the time. So the raw materials, they dropped to 285. The assembly, it costs $150. It keeps the same cost. The storage in China, it went to 1438, so which it was an increase in the storage of around 10%. And the shipping, it keeps the same value of $15. And the warehousing went a little bit down to $11.25 per TV. So the total was a TV during the COVID cost per TV was $475. Compared to the previous cost was $490. Indeed, we reduced the cost during the pandemic. Now, the EOQ, the economic order quantity, it was 8,451 units. Little bit less compared, well, not a little bit less, but almost 1,000 TVs less compared pre-COVID conditions. Now, in the labor shortage and the operational constraints that we have, so the labor reduced 25%. And maximum receiving capacity was of 7,500 units per month. Therefore, the maximum feasible order was 7,000 units. Now, in inventory and order cadence, so we have starting inventory at 6,500 TVs. That is our starting point, our initial condition. And then the orders became at 7,000 units to be replaced every 2 to 3 months with 3 to 4 months of lead time. In other words, every 2 or 3 months, we put an order for 7,000 TVs. But it will take 3 to 4 weeks, 3 to 4 months on lead time. So to avoid stock outs and align with limited labor capacity, we need to consider this fundamentally. The profit forecast. The profit forecast for the model over the 12 months shows an initial dip followed by the gradually recovery, aligned with a demand that rebounds the projections of 5 to 10% increase or growth per month. So eventually, after the collapse, a small recovery is going to take a place. So that was the final conclusion, was that we stayed in business and we are poised to recover with strategic operational resiliency and with executive decisions based in the data. So informed decisions, resiliency in operations, maximizing the profit, minimizing the cost, and be more cautious to act under uncertainty. Well, this is the video. This is what I wanted to explain during the presentation. But as I said, very unfortunate, my son has this illness, and it was very difficult and complicated. Apologize to the entire class. Apologize to the professor, to the TAs as well, and I send you this video. Thank you very much for your understanding. Thank you.